Hello friends, welcome to this YouTube channel. Today we are going to solve one numerical problem on three-phase medium length transmission line. By solving this problem, we shall learn how to determine sending end voltage, current, power and power factor of a three-phase medium length transmission line when values of load details and generalized constants ABCD are given. A 132 kilovolt 50 Hz three-phase transmission line has the following generalized constants. A equals to D equals to 0.99 at an angle 0.3 degree, B equals to 70 ohm at an angle 69 degree, and C equals to 400 micromho at an angle 90 degree. We have to determine the sending end voltage, current, power and power factor if the delivered load at the receiving end is 45 megavolt ampere at 0.8 power factor lagging. Let us now write down the given data. Load SL equals to 45 megavolt ampere, that is equal to 45 into 10 to the power 6 volt ampere. Line to line receiving end voltage VR line equals to 132 kilovolts, that is equal to 132 into 10 to the power 3 volts. For star connected system, receiving end voltage per phase VR equals to VR line divided by root 3, that is equal to 132 into 10 to the power 3 divided by root 3. That gives us 76,210 volts. Given load power factor cos phi L equals to 0.8 lagging. Let us now calculate power factor angle. Phi L equals to cos inverse 0.8, that is equal to 36.8699 degree. Expression for load SL equals to root 3 times VR line into IL. Therefore, load current IL equals to SL divided by root 3 times VR line. Using values we get 45 into 10 to the power 6 divided by root 3 into 132 into 10 to the power 3. That gives us 196.824 ampere. Load current may be written in polar form as IL equals to IL at an angle minus phi L, that is equal to 196.824 ampere at an angle minus 36.8699 degree. In this case, load current IL is the receiving end current IR. Taking receiving end voltage per phase as reference, we can write VR equals to 76,210 volts at an angle 0 degree. We have computed receiving end current IR equals to 196.824 ampere at an angle minus 36.8699 degree. Given generalized constants A equals to D equals to 0.99 at an angle 0.3 degree, B equals to 70 ohm at an angle 69 degree, and C equals to 400 micromho at an angle 90 degree, that is equal to 4 into 10 to the power minus 4 mho at an angle 90 degree. Expression for sending end voltage per phase Vs equals to A times VR plus B times IR. Using values we get 0.99 at an angle 0.3 degree into 76,210 210 at an angle 0 degree plus 70 at an angle 69 degree into 196.824 at an angle minus 36.8699 degree. That gives us 87,114.393 plus j times 7,722.61 volt. This may be written in polar form as 87,456.024 volt at an angle 5.066 degree, and sending in current per phase Is equals to C times VR plus D times IR. Using values we get 4 into 10 to the power minus 4 at an angle 90 degree into 76,210 at an angle 0 degree plus 0.99 at an angle 0.3 degree into 196.824 at an angle minus 36.8699 degree. That gives us 156.4946 minus j times 85.612 ampere. This may be written in polar form as 178.38 ampere at an angle minus 28.6813 degree. We have obtained sending end voltage per phase Vs equals to Vs at an angle delta equals to 87,456.024 volt at an angle 5.066 degree, and sending end current per phase Is equals to Is at an angle minus phi 1 equals to 178.38 ampere at an angle minus 28.6813 degree. For star connected system, sending end current per phase equals to sending end line current, and line to line sending end voltage Vs line equals to root 3 times Vs, that is equal to root 3 into 87,456.024, which is approximately equal to 151.48 into 10 to the power 3 volts or 151.48 kilovolt. Phase difference between Vs and Is, phi s equals to delta plus phi 1. Using values we get 5.066 degree plus 28.6813 degree. That gives us 33.7473 degree. Let us now calculate sending end power factor. Cos phi s equals to cos of 33.7473 degree. That gives us 0.8315 lagging. Now we shall calculate sending end input power. Ps equals to 3 times Vs into Is cos phi s. Using values we get 3 into 87,456.024 into 178.38 into 0.8315, which is approximately equal to 38.9 into 10 to the power 6 watts or 38.9 megawatt. So today we have solved one numerical problem on three-phase medium length transmission line. By solving this problem, we have learned how to compute sending end voltage, current, power and power factor of a three-phase medium length transmission line when load details and values of generalized constants A, B, C and D are given. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.